together a slash state for our player character, the standing slash state to be exact. And this time we are going to carry on with that by adding in some additional features such as the ability to shoot a laser and duck slashing and basically anything else we can fit inside of our time period here. So let's get cracking on that. All right, so previously we had some code in here for all these different features that we're talking about, such as the ability to damage all enemies in a list by triggering their damage state. So we can't actually implement this yet until we actually have an enemy to implement it on. So we'll ignore this for the moment. But what we can do is generate a sword beam when we are at full health. So I'm going to uncomment this code here and we'll go over what we're doing here. So first off, we have here a little thing that says if global current save data current HP. So if our current HP is equal to our maximum HP, then we can generate a sword beam. You'll note that this is not inside of any particular area. It's actually something that's being tested at all times here. But actually, it's on frame 7 will actually be when it actually happens, because we have this right here. Now, I could have made made it part of this, I guess, if I wanted to. But I didn't think about doing it that way. I did it this way, and now it's this way. But you can just add an extra else if frames and states equal to 7, then basically do the same thing, except now reverse it. So, and if instance doesn't exist, object sword beam, because we don't want to be creating sword beams if we already have a sword beam on the screen. So audio plays sound, SFX sword laser sound effect. That little guy. And var underscore direction is equal to facing direction. You'll see this code a lot. So we're basically saying, okay, if we're facing to the right, then we want 1. Otherwise, we want -1 for multiplying our position variables by. Var underscore instance create layer xy -21 effects sword beam underscore inst dir dot direction underscore inst dot dir underscore is equal to underscore dir. So we're setting up the direction that our sword beam goes in as being either 1 or -1. So in the sword beam, we're multiplying a direction by 1 or -1 to determine which direction it goes. Same thing for the image X scale of the laser beam. So we have this object sword beam here. Let me go over here to my other objects and see where exactly do I put this. Yeah, I just put it under a link here. So create a new object. obj underscore sword underscore beam. And give it a, before I forget, yay, got the text zoom in there. So then we go object sword beam, and we do let's see, pop it open over here, create and a step event for this guy. In the create event, we set the image speed equal to 1 because the sword, oh yeah, that should probably give you the, nope, that's the enemy death effect. Link sword beam, there we go. The sword beam has a little blinky animation going on. So image speed equals 1, direction is equal to 0, which we set to either 1 or -1 based on this. Speed is equal to 2. And life timer is equal to round 0.5 times sec. And I believe the lifespan is shorter in the PAL version because PAL runs at 50 FPS instead of 60 FPS. So something to keep in mind when you're doing things. Damage underscore is equal to global.current save attack level +1. So that's how much damage the sword beam will do. it's whatever your attack level is plus 1. Because remember, attack level starts at 0, so we have to add 1. Okay, so this is a little function method I've set up, so just end me. Image speed equal to 0. Sprite index equal to sprite sword beam end effect. So this little guy. And we'll actually animate that in the step event here. When we come over here to our step event, we have a simple state machine based on the sprite index, as I mentioned. So if we have the sword beam, then we should be checking for our lifespan. And rounding ensures that I will always be an int, even in funky HTML export. I don't know exactly how important this is, but I'm doing it. So just something to keep in mind. So once the lifetime is equal to 0, then we want to end me and time down our timer after we check for the 0 point. Then generate a hitbox. So this is basically going to be exactly like this right here for the player, except we are doing it over here. So just because we can't actually do anything with it quite yet, and we don't want to cause the game to crash when we try to run it, we'll just cancel all that code out for the moment. We have just to go over a little bit about how it works, we create a instance list, and we use a collision rectangle list, and that basically says, okay, everything that's inside of my hitbox that is a parent enemy, then a bunch of stuff that doesn't really matter, gets thrown into the inst list. And then basically we loop through every single value in the instance list, if there are any in there. And if they are, then have them take damage. Then remember to destroy the instance list. Get used to using the collision list functions, actually, because that's how you allow your player to hit multiple characters or multiple enemies at one time. So, I mean, if you don't want your character to be able to hit multiple enemies at one time, then I guess it doesn't really matter. Anyway, so case sprite sword beam end effect. If animation end, instance destroy. Very simple, right? And move me until I die, disregarding walls because he doesn't care about walls. X plus equal dirt underscore times speed underscore. So very simple. Movement with no collisions. And this is an FPS of 8 instead of 4, so just keep that in mind. All right, so that's everything you need to be able to do to be able to create a sword beam effect. Let's see it in action, I believe. It should work, I hope, right? There we go. Yeah, see? There he goes. Seems a little low, but whatever. Yeah, it's 1 pixel low for some reason. Oh well. You can adjust how high it is when it's created by changing this. So, there you go. That'd fix it. Just some notes by me about what the game did versus how I would do it if I were doing it. Let's see here. We are currently at, 9 minutes and 34 seconds. So let's go and make the ducking slash state. That'd be this guy. Ducking slash state. And well, I'm going to copy from my setup. You can copy from your setup by using, let's see, there we go. by using basically copying the standing slash state, and then we're going to edit in some of the duck state stuff to it. So as you can see, the the ducking slash state can go either into the jump state, the duck state, or the move state. So the normal duck state. Normal duck state is must be ahead of move to supersede it. So if I'm still holding, oh yeah. So basically, we want to go into the duck state, preferably ahead of going into the move state. So if both situations that would let you go into the move state and the duck state are both relevant, then go into the duck state preferably over the move state. Such as if you were sliding, then you go into the duck state instead of going into the move state if you're holding the down button while you're doing a slide. So if the input is held down, frames of state is greater than 13, then go into the duck state. Very simple. Move state, if frames are greater than 13, go into the move state. And jump state, if the input is pressed jump, then go into the jump state, basically the same as all the other jump states. Not checking ledge, because when you go into the slash state, you lose all movement speed. So theoretically, you can go into the jump state, but you can't go into the jump state and go over a cliff at the same time. Hopefully, you probably can. So I don't know. I haven't had any issues with it, but it's just a one frame sort of trick. If somebody were to be able to do this, pull this off. So this is basically going into the jump state again, like normal. Got all those states. Acceleration. Ducking state cancels all X momentum, so shouldn't be able to reach a state while in the Y. So while in the air, so Y isn't accounted for. So just cut your X fractions to nothing, your current X speed to nothing, your applied X speed to nothing. Speed fractions, not in there because there is no movement. Collisions, not in there because there is no movement. And animations, well, that's where everything happens. So we're basically doing the same thing as the slash state. We have our little sequence of animation. So if the frames of state are greater than 8, then return to the regular ducking state. If the sword slash audio is not playing, then play the sword slash audio. That little noise. And then generate a hitbox. Again, we'll cancel that for the time being. Same hitbox thing set up as with the main player. And DS list destroy. Make sure you destroy that so you don't have a memory leak. Oh, yeah. So this just generates a sword when you are in the first couple of frames of the state. And this generates a sword beam. Same code. Except now, Y is at 11 instead of 20. And if that one was low, this one would also be low, so put that at 10. X scale equals facing direction, which is equal to dir.right, and frames in state, plus plus. All right, so that was easy, right? It's all basically the same stuff as previously we've covered, so shouldn't have any trouble implementing it if you've paid attention to the previous lessons, right? So down, and we can't actually do anything because I haven't actually implemented it yet. We need to be in the duck state, ducking slash state, and we're just basically going to do the exact same thing that we did to get into the slash state. If the negative input is pressed, reset the buffer, and go into the ducking slash state. Let's check on these guys. So need the jumping slash state, which will be basically covered. Standing slash state is covered. Good. Now it's too low. That would actually be because you should be at 12, not 11. I guess you should be at 22. Anyways, let's see if we can squeeze in that jumping slash state as well. Since we're doing slash states here, we might as well finish them all up, right? If we can do that. So jump state, jumping slash state. Again, the same code. If the input is pressed, go into the jumping slash state. And the jumping slash state is number 8. There we go. Landing state. It's again, we're going to basically be copying all of our code from the jump state over here into the jumping slash state. So landing overrides the slash. So basically, you go into the landing state, cancel your Y speed when you land, and yeah, continue as if you're normal. Jump state, if frames in state are greater than 30, then we can go into the jump state, or I should say, we are forced into the jump state because we're probably still in the air, and at this point, well, we're forced in the jump state, but we don't actually do any of the jump code, so we will not have any problems with being able to get a double jump somehow. I hope. Acceleration, coyote time, variable jump, X input, apply gravity, all the same. We're just doing it, copying it, speed fractions, all the same, copying it, collisions and movements, all the same, copying it, animations. Again, we're going to do the little state system, frames in state greater than 22, go back to image index 0, frames in state 14, image index should be 0, and we should have the sprite links idle. And when we're in greater than 8, image index should be equal to 1. And all this comes back to the sprites link standing slash, I believe. I don't know if I have a jumping slash. Yeah, because he just sort of does a standing slash in midair, I believe. So you are changing between the different animations, same as with the standing slash state. So generate a hitbox for each frame, etc. Cancel out this bit so we don't crash the code. Actually, we do have parent enemy, and we don't actually have to cancel out this code, actually, because we aren't actually calling out any specific enemy. We're just calling out parent enemy. So let's actually go back to all of our code here, and cancel this out because it shouldn't actually crash anything. All right, good. DS-list destroy inst. Generate a sword beam for a full health. Mine minus 22. If frames in state is equal to 9 instead of 7. If frames in state are greater than 7 and Y speed is less than 0, then we should be in the duck state, just like in the jump state. If the Y speed is less than 0, then we're in the duck state. Or, well, we're using the duck animation because he's pulls up his legs at the beginning of his jump. Else image index is equal to 0 and sprite is equal to jump. And image index is equal to 0, finally. Image X scale is equal to direction, so just flip our direction around and frames in state. So yeah, all this stuff is just the same thing we've already been doing, copy, paste, and make some small minor tweaks if needed. So, and we don't really have any small minor tweaks going on. That should be good. Let's go take a look at it. There we go. You can see if he you hit the slash, but he hits the ground before the slash completes, he interrupts. Same thing for the duck state. There you go. So you can see when you land, you interrupt your attack. Very good. Alright, so everything is going well so far. Alright, I think that's everything we can go cover on this episode. We got all of our slash states finished. So that just leaves damage and, let's see. User event 5. What would be user event 5? 5 is find treasure, and we don't have find treasure because I only use find treasure for the Patreon names. Speaking of which, I'm going to let Past Me take it away with Patreon names. I'd like to thank my legacy Patreon sponsors: James Burton, JV Lowe, Suli, and Vezia. I'd also like to thank my current Patreon sponsors: Kenneth Klein, Vladimir, and Jamal. Thanks to your support, the NESGameMaker is much cooler, and I'd like to wish you all good luck with your programming.